Hello students, this is lesson U4A04c. By the end of the lesson, you should be able to say I can use properties of sides, angles, and diagonals to identify a rhombus or square in a geometric proof. So let's take a look at our first proof related to rhombus and squares. Okay, so I encourage you to pause the video and try this problem out on your own. Let's write down all the necessary givens into the problem and then see what you can do with it. So welcome back. Hopefully everyone had a chance to try this. Well, looking at this, I noticed immediately that we have several triangles that are congruent to one another. So let's try to talk through the logic before we talk about the actual proof itself. So immediately I see that triangle ABF, which I'm going to highlight there in red, is congruent to EDF, which is this guy right there. And I also know that CDF, and I also know that EDF is also congruent to CBF. CBF. So it's this guy right there. And I also know that triangle CDF is congruent to ABF. So because CDF is congruent to ABF and ABF is in pink, then that means this triangle should also be in pink. So can you see now that all four of these triangles, because of the three lines that are posted here, that are given in the in the givens, that all four triangles are in fact the same. All four triangles are going to be congruent. And then because of this, okay, our goal is to determine that BCDF is a rhombus, and you're told that CD is congruent to DF. So that means, and here I'm going to use another color to indicate this. Let's use the color blue, okay? That CD is congruent to DF. We need to show that it's a rhombus. So if CD is congruent to DF, I'm sorry, I mislabeled. CD and DF are the same. So if those two are the same, then that means the other side over here, corresponding parts of congruent triangles, must be the same. So, and therefore, all four sides are going to be congruent. So therefore, quadrilateral BCDF must be a rhombus because all four sides are congruent. So that's the logic of it, okay? Now, how do we describe all this? So the logic, so the first thing is we try to link all the different triangles together, right? So I can say that CDF is actually congruent to EDF. CDF is congruent to EDF because I'm performing a substitution here between line 1 and line 2. That was actually one of the first things that we did. So again, CDF is congruent to EDF. Okay? And then we also recognize that CDF is also congruent to CBF, and that is because we performed yet another substitution between line 3 and line 5. And then lastly, since we know CDF is since we know that triangle CDF and CBF are congruent, we can therefore declare that CD must be congruent to CB because of corresponding parts of congruent triangles are congruent. We also recognize, because CD is also congruent to DF, we can also say that DF must therefore be congruent to BF. Because of, again, CPCTC. So because DF is congruent to BF, and we know that CD is congruent to CB, we don't really quite have all the sides are congruent yet, because look, CD is congruent to CB, and DF is congruent to BF. We need to link all the sides are congruent to one another. We're going to say that CB is really congruent to CF. I'm sorry, is congruent to BF, which again, we're performing a substitution between 7, 8 into line 4. And the purpose of doing this is to show, again, that CB congruent to BF and CD is congruent to DF. Therefore, I can say that all four sides must be the same. And this is because I'm substituting line 4, line 8, and line 9 all together. All of these things are actually linked and connected and are one and the same. And then the final statement is that BCDF is a rhombus because all sides are congruent. Let's take a look at another example. Okay, so pause the video and see if you can figure this out on your own. Definitely write down all the necessary givens, okay, which is just one line, which is all 4 triangles are congruent. All right, hopefully everyone got the chance to figure this out on their own. I am just going to talk about this logically with you guys first. First, let's notice that triangle AID is congruent to BIA, which is congruent to CIB, which is also congruent to DIC. We need to show that this is in fact a square, okay? So if this is a square, okay, there are a couple of ways in which we can do this. We can show that, remember, there are different properties that we can utilize, okay? But again, first and foremost, let's just talk about this. All 4 triangles are the same. If all 4 triangles are the same, then immediately I recognize that this side corresponds to that, which corresponds to this, which corresponds to that. All 4 sides will be congruent. And that's enough actually to show that it's a rhombus. What we need to show is that it's a square. Because of this, okay, we know that AI and IC are going to be the same, and DI and IB are going to be the same. We need to then show that all of the diagonals, when added together, are actually the same things. So how are we going to do that? Well, we're going to need to use segment addition postulates, okay? This is not the only way that you can do this. You can also try to determine that all 4 angles, or one of the angles there is 90 degrees, but we're going to have to use angle addition postulate. You can certainly try to do that, but I'm going to approach it using segment addition postulates, okay, to show that the diagonals are in fact the same things. So let's take a look. So one of the first things that I want to do is, after the given, having the understanding that all 4 triangles are the same, is to recognize that AD and BA and CB and DC, in other words, all 4 sides are the same, right? And this is because of CP/CTC. Corresponding parts of congruent triangles are congruent. I also recognize that not only are the 4 sides the same, now I want to talk about the diagonals a little bit, or the parts of the diagonals. I recognize that AI is congruent to BI, which is also congruent to CI, which is also congruent to DI. All of those lengths will be the same. Again, because of corresponding parts of congruent triangles are congruent. All of these lengths are the same. So the next step here, okay, what I'm doing, remember in the very beginning of the year I said that there was slight difference, okay, between congruence and equality. Well, the way in which I had approached it in past years is to actually convert something from congruence to equality. You do not need to do this in step 4 here. So you do not need to convert something from congruence to equality. You do not need to do that. So we're going to skip that. But what we're going to do is we're going to demonstrate, again, you do not need to do this, so for the next couple slides, I'm going to be actually getting rid of that. So what we're going to demonstrate that AI plus CI is equal to AC. And why is AI plus CI equal to AC? Well, that's because of segment addition postulate. I want to also show what is the other diagonal made up of, which is BD, right? BD is made up of BI plus DI. So we're going to keep on getting rid of this. All right, and the same reason, it's because of the segment addition postulate. And my goal for the next couple minutes is to show why is AC, you know, one of two diagonals, is congruent to the second diagonal, BD. Well, in order for me to do this, I'm going to need to perform a series of substitutions. I need to show why AC is congruent to BD by utilizing the information that was shown in line 3. Okay, so how are we going to do this? I know that AI plus AI has to equal to AC. And why is that? Well, that's because AI plus CI, and I know that CI is equal to AI. So therefore, I can say that AI plus AI is equal to AC. And this is because of substitution. From which lines exactly? It's from lines 3 into line 5. Again, I know that AI plus AI is equal to AC because I'm substituting information from line 3 into line 5. Next, again, I also know that BI plus BI is equal to BD because I am replacing DI with BI, and that is also because I am substituting information from line 3 into line 8. I'm sorry, substituting information from line 3 into line 6. So now that I have this, okay, I know that AI plus AI is equal to AC, okay, from line 7. I know that BI plus BI is equal to BD from line 8. Looking at this now, wait a second. I need to link, right? But wait a minute. What was AI? What was BI plus B? What is another way to represent BI again? Well, what is another way to represent AI again? My mistake. Okay, AI is the same length as BI, isn't that right? That's also from line 3. So I can replace AI plus AI equal to AC because of the fact that AI is really the same thing as BI. I can replace that, okay, and rewrite line 7 by using the information from line 3. I can rewrite line 7 by using the information from line 3. So because BI plus BI is equal to AC, and I know that BI plus BI is equal to BD, my 10th statement is to say that actually BD and AC, or AC and BD, are the same things. So because AC and BD are the same things, then that means I have congruent diagonals, right? This is true because I'm substituting line 8 and 9 together. So because I know that AC is the same as BD, okay, and I know that all 4 sides are the same as shown in line 3, my fourth and final statement can simply be that ABCD is a square. And why is it a square? Well, that's because all 4 sides are congruent and diagonals are congruent. Okay? And that's it.